peak versus RMS. RMS stands for root mean square. Okay. Now, what we've got is, if we consider voltage, we've got a voltage changing like that, AC waveform. Yep. Peak is that. What RMS is a straight line value. That's what's usually quoted as the nominal voltage. 230 volts, 400 volts for our system. Guys, you just give me this 5 minutes, yeah? And it's done that way. The RMS voltage is the voltage that would give the same power. So if we're talking about 400 volts RMS, that's the voltage that would give the same power in the same load as 400 volts DC. It's like the equivalent to the DC voltage in AC. Yeah? And for a perfect sine wave, for a perfect sine wave only, RMS is equal to peak over root 2. Yeah, so if you, our 400 volt system, multiply 400 volts by the square root of 3, what do you get? Now if you divide 400 by root 3, you'll get 240. I'm looking for the peak voltage of the 400 volt system. So multiply 400 volts, which is the RMS value of the line voltage on our system, by square root of 2, what do you get? 565 volts. So our 400 volt line, 400 volt RMS, peaks at 565 volts. Yeah? It's important to know the peak, and you talk about putting capacitors in for power factor correction. They need to be over 565 volt working, because they're going to be charged up to the peak voltage, not the RMS value. So you usually use 600 volt working capacitors. Okay? By the way, meters measure, i.e. amp volt ohm meters that you buy, digital or analog, measure RMS values. If they're cheap ones, they only give you a true reading for a true perfect sine wave, because they use this formula to convert between the average reading they measure and the RMS value. If you want to measure true RMS of any AC wave shape, you need to buy a true RMS meter, which is much more expensive. When I was still in the game, that was the difference between, say, a £200 meter and paying nearly £1,000 for one to get a true RMS. Probably not as much difference now. Is that, yeah, a cheap 20 quid meter or 200 quid true RMS? Yeah, so things have changed since I've come out of being yeah. Yeah, I mean, personally, I wouldn't pay 20 quid for a meter and put that on main systems. But that, you know, I wouldn't do that. I'd need to buy something a little bit more.
But that 20 quid one's probably much further than probably what you're saying that way, that we're paying a couple hundred quid for.
No, exactly. But the thing to me, the other thing I don't like is I don't like auto ranging. I hate it. I like to pick my range. And I'll tell you why, if you're in if you're in low lightish situations where you're working in the back of a panel, that's easy to see like some spurious kind of voltage spikes, 250 millivolts, microvolts, because that's on auto ranging. Whereas if you had that on 250 volts because you're expecting 230, then you put it on that tiny little voltage, you ain't going to see nothing. Yeah. So I like to choose my range. The other thing is, if you're on the cusp of between ranges that keep switching range, I just don't like them. I'm old-fashioned, I know, but select the proper range, know what you're looking for. And if you don't know what range you should be putting on, you should, in my opinion, shouldn't be using the meter. That is as simple as that. Yeah. But each to their own, but I don't like, and if I'm absolutely honest, I'm just as happy with a nice Ava 8 and an analogue
So you've
reader.
very hard now to buy like a couple £100 worth of meters that would be all range. Like all the most more expensive ones are all range.
Probably do,
Most
probably
people
do.
prefer all range, and obviously it's easy.
But I still got my select my own range meter in my toolbox. Right. So that's the difference between RMS and peak. So RMS for a sine wave only is the peak of a root 2. So you can twist that around to go either way. You can go from peak to RMS. All right.